Hello, and welcome to Beyond the Gates. This season, we're talking about 7 Labs, 1 ERDC. I'm Annette Kirkland. Discover the power of ERDC's 7 laboratories as they bring their technical expertise together to solve the nation's toughest challenges, from developing technologies that support the warfighter to improving the civil works systems we rely on each day. See how each of these 7 labs play a unique role in engineering a safer, better world. Today, I have 2 guests with me, Dr. Jonathon Brame. He's a research physical scientist, and Justin Campfield. He's a public affairs specialist, and they're with the Cold Regions Research Engineering Laboratory, otherwise known as CREL. Good morning.
Good morning.
Good morning. Thank you for having us.
Absolutely. Thank you guys for doing the show, and we're really excited to get to know CREL a little bit. And let's start off with my favorite question. We're going to talk about you guys. So could you tell me about yourselves, your background, and explain your roles at CREL?
Yeah, sure. I'll go first on that. So my name is John Brame. I came into the ERDC through the DoD SMART program way back in 2008. So almost 20 years of connection with ERDC. I started with the environmental lab doing material science research, trying to understand how nanomaterials would impact soldiers and health and performance. A couple years of that, eventually moved to D.C., where I was a liaison from ERDC to the Pentagon, which was a lot of fun, really interesting. And then took a little break and jumped over to DevCom, where I was the international basic and applied research lead over in London, England. It was really fun, 6 years learning all about DevCom and Army Futures Command and international science and technology. Really interesting job, cool people, a really fun mission. And then just this past year, I moved back to ERDC, where I landed here at CREL. I am currently technical director here in the Office of Technical Directors at the Cold Regions Research Engineering Lab in Hanover, New Hampshire.
Sounds great. Justin?
Yeah, I've been at CREL for not quite 3 years. I have spent my entire career in communications and journalism, either on the corporate PR side or as a working journalist. I think as CREL's public affairs officer, my job is to represent and promote the lab to outside audiences, and I like to tackle that by pretending that CREL is a city and that I'm the beat reporter at its local newspaper. So basically, my job is just I keep my eye out for things that I think people will find interesting, and then I get to write about them.
And get to do cool things like a radio show.
Radio shows, I do some videos. Yeah, we're not just one dimension anymore, for sure.
Well, sounds great. So again, based in New Hampshire, CREL has a very distinct identity and unique mission. Could you tell us about CREL and explain how your cold regions research is a vital component of ERDC's effort to solve the nation's toughest challenges, and specifically how operations at unique facilities like the permafrost tunnel in Fox, Alaska help that research?
So I'll take that. I think CREL, it's easiest to think about us in that we specialize in ensuring that the U.S. can occupy, operate, maneuver, and win in the world's most demanding, extreme cold and complex conditions. Now, if I was going to put that a lot more simply, it's just stuff does not work when it's negative 50 degrees out. And it's our job to make sure that it does. So what do I mean when I say stuff doesn't work when it's that cold? Well, batteries don't crank, soldiers' water freezes up, metal snap, frostbite and cold injuries can take out even the fittest soldiers, and moving people and supplies from point A to point B is just very, very tough in those conditions. So those are just a few of the problems that our team of 200-plus professionals here in Hanover and at Fairbanks work on every day.
Sounds great. John, do you have anything to add?
Yeah, I'll just chuck in that CREL is the only cold-specific research lab in the U.S. government, and so we do a lot of interesting work to support all sorts of science and engineering in the cold, not just with the Corps of Engineers or the Army, but across the whole Department of War and all of government.
Well, so let's go back to the beginning. So how did CREL actually get started?
Well, CREL was officially formed in 1961, but I think in a way you can trace our origins even further back to the aftermath of the bombing of Pearl Harbor. Mm-hmm. So there was a major concern that Japan would invade Alaska and then continue into the continental United States. So in 1942, the U.S. Army built a road that linked the contiguous U.S. with Alaska, and that road, now known as the Alaska-Canada Highway, was completed in 9 months in just unbelievably difficult conditions. And it's really known as one of the U.S. Army Corps of Engineers' greatest achievements, putting it alongside even the Panama Canal. But during construction of that road, we encountered something called permafrost, and there wasn't a whole lot of understanding about permafrost at that time, how to build with it, how to build on top of it, and how that permafrost would change, and then the infrastructural impact that those changes would have. So we just didn't know a whole lot about it. So shortly after the war, the Army began to study permafrost in greater detail, and they were doing that in multiple labs, and those efforts were eventually combined in 1961 to create CREL here in Hanover, New Hampshire.
That's quite a beginning. John, do you have anything to add?
I mean, I'm kind of new to CREL. I had heard quite a bit about it, back when I was at the environmental lab and an ERDC liaison. But it's been really fascinating being here and seeing not just the breadth of research, but of kind of historical precedent. Like Justin said, some of these problems were brand new. Nobody understood what to do with them, and CREL kind of has been there solving those extreme cold problems for a long time.
Sounds great. And the theme of our show this season is discovering the power of ERDC's 7 labs, united to solve challenges. Can you provide an example of how CREL has partnered with another ERDC laboratory to tackle a challenge that neither could have solved alone?
Yeah, I'll go ahead and tackle this one. This is kind of CREL's bread and butter. Excuse me. So because our competency is in the area of cold science and technology, that's not a warfighting function all in itself. So almost everything that we do is in support of or working with other groups across ERDC, across the Army, and beyond. Lots of great examples to choose from. I'll briefly mention a couple. So one has to do with mobility tools. So ERDC for a long time has had a lot of expertise in mobility, moving across different types of terrain, whether that's the geospatial element or the geotechnical element, or in our case, the cold element. So we've been able to partner with folks in the environmental lab and GSL and elsewhere to create a winter route planning so that soldiers can understand the impacts of snow and ice on various types of vehicles and whether they'll be able to transit a certain area safely. We also work closely with the Construction Engineering Research Lab, some of their energy capabilities to move those energy production facilities into cold and austere environments, making sure that fuel lines don't freeze and we can keep power going to the troops. We also have worked closely with the environmental lab on the ultralight electromagnetic array, which is able to detect unexploded ordnance underground, and working with them now on a new project to kind of take that really unique sensor that can find metallic objects in the soil and see if we can use it to find mines and other things in the water, which is a very challenging topic. The last one I'll hit on briefly is runway repair. So, of course, ERDC is very strong in all things concrete, asphalt, and how they work in different environments. The cold is a very unique and challenging environment for concrete. How do you keep the concrete soft while it needs to be soft and put it where it needs to be placed? And then even setting and curing can be a real challenge in the cold. So working with scientists across ERDC to be able to, for example, build, maintain, and repair runways up in the Arctic and even in the Antarctic is an area where we've collaborated with some of the core competencies and expertise around the whole of the Engineering Research and Development Center to solve those incredibly difficult challenges, as you mentioned.
Collaboration, so important. So, Justin, do you have anything to add?
I don't think I can improve upon John's answer, so I'll just leave it there. It was great. It was well said.
Okay, sounds good. Okay, so a key pillar of ERDC's mission is military engineering, and CREL plays an important role in protecting our troops and giving them an operational advantage. Can you tell us about CREL's technology that support the warfighter?
Oh, yeah. I'll take this one, too. This is one of the things I've really enjoyed learning in my couple months here at CREL is some of the unique ways that we've been able to support the warfighter. I'll try and limit it here just to two really interesting stories. So this past year, our researchers were working with Canadian partners and the New York Air National Guard on Operation Nanook, which is a exercise up in Canada where troops from the U.S., from Canada, from elsewhere work together to kind of practice how we operate in the cold. And this particular effort was the first ever landing of an LC-130 aircraft on an Arctic lake, so landing on the ice. So LC-130 is a very large airplane, and it's been outfitted with skis instead of wheels.
Wow.
And our engineers were able to go up to this frozen lake, measure the ice, calculate the thickness and how that translates into strength, and give a very strong vote of confidence that the pilot would be able to land what is a very large, very heavy aircraft on lake ice. I'm not sure that I would want to be the pilot making the first landing, but very, very, very brave pilots with a lot of trust in the ERDC expertise to say, hey, there's enough strength in this ice to land an aircraft. And they were able to do it successfully, no problems. They recorded it all in a great technical report, and were able to kind of expand the area of operation for where we can now land airplanes. Up in the north, in the Arctic, there's not very many accessible runways, and military logistics is a huge thing. So whether or not we can get personnel and equipment in and out can determine whether or not we operate in an area. So being able to land on frozen lakes and understanding when that is and particularly is not safe can expand our operational reach by as much as 25% up in those Arctic areas. The other one I wanted to touch on real briefly is work with the 11th Airborne Division out in Alaska. They are participating with a lot of other military units in the Department of War's Drone Dominance Program, which is an effort to put out a whole lot of very small unmanned aerial systems, UAS, small drones, into the hands of soldiers, kind of in response to what we've seen in terms of conflict over in Ukraine. So the goal is to down select from a whole bunch of different companies and find the best drones to send out tons of these systems out to the soldiers. The 11th Airborne, when they tested their systems in the winter this past year, they found that the batteries didn't work. They had really short lifetimes, and sometimes they weren't even able to turn the drones on. So they expressed some of these concerns, but the next 2 rounds of drone dominance are happening over the summer. So the 11th Airborne contacted us, and they said, hey, we won't be able to test these in the cold. Can you guys help us out? So we're working with them to get some of these brand new systems, bring them into some of our exquisite cold rooms where we can turn the temperature down to as low as minus 60 Celsius, and cold soak the drones, see if they'll turn on, fly them around in some of our large facilities, and just see and understand how the cold impacts those systems. So as the department is purchasing, tens, hundreds of thousands of these, we understand how they will, or in some cases won't work in the cold.
Right, right. So when you were speaking of the plane landing, how cold was it there?
It was very cold. So it was wintertime in Canada. I think the temperatures were down about negative 20. So
that gives a chill just listening to that.
I know, yeah. There is a little bit of adaptation. We were in a tour recently in one of the cold facilities. We had some folks from the Office of the Undersecretary of War for Research and Engineering. Mm-hmm. And we knew we were going into the cold, so we were all bundled up in our coats. And some of these same researchers were in there at, I think it was 5 degrees at the time. And they were just in a light jacket, holding metal gear and handing out snow samples to the visitors. I tell you what, I was not prepared for that cold, but they sure were.
It is a different type of cold. Justin, do you have anything to add?
Yeah, just last week I experienced something that is a great example. I was in an extreme cold chamber down to negative 40 degrees where we're testing some equipment with the U.S. Navy to help provide drinking water to warfighters. So when it's that cold, even the simplest of things become very difficult, as we've been mentioning. So that was just this past week, and it's just one example of landing a LC-130 on frozen lake ice is unbelievable, and it's amazing that we can do that. That's kind of on the higher end in terms of technical difficulty. On the low end is just simply trying to have drinking water for people to stay alive. So it's a big spectrum of importance that we cover.
Yeah, the power of ERDC is pretty powerful. So mm-hmm. Transitioning to civil works, extreme winter weather can cause a dangerous domino effect across the country, from ice jams to deep freezes that cripple our power grids and transportation systems. How does CREL leverage its ice engineering expertise to tackle these threats and ensure our communities stay safe?
Yeah, that's a great question. I'd be happy to talk about that. I think that our research scientists, they tackle ice in from two angles, really. One is how to prevent it from forming, and then how do you mitigate its impact when it does form. So they look at the ice at the molecular level, and they use that understanding to attempt to inhibit the formation of ice to begin with. And one big area effort right now is paints and coatings that, when applied to a surface, and we're talking airplane wings, power lines, lock walls, once applied to that surface, it prevents ice from forming, and there's a lot of really interesting research going on and projects in that area. Another is using antifreeze proteins found in fish to create skin cream that prevents the frostbite. So there's something in that fish that allows them to live in these extremely cold conditions, and their cells don't freeze. Right. And so what is it that's allowing that to happen from almost a biological standpoint, and then how can we learn from that? So that's kind of, how do we prevent it? You mentioned ice jams, which are a major issue for many communities, and including it's quite a big deal here in northern New England. And we have a team of research scientists that tackle that in three ways. One is maintaining a national database of ice jams that alerts communities and emergency management officials to emerging risks. So that's continuously updated. And so it gives a little bit of a heads up or warning to these communities that are at risk of ice jams. Second is our scientists can conduct hydraulic analysis, which is, essentially studying a river, its topography, how it flows, and, understanding whether those characteristics are preventing ice jams or promoting ice jams, and then what can you do once you realize that they're promoting ice jams. And the third is really engineered solutions. So these are ice booms, levees, and then thermal melting, and these engineered solutions can help prevent ice jams from forming or break them up. Once they do form, break them up before it becomes critical for towns, and then you have the flooding. So ice jams are a really complex problem, and they require a multi-pronged approach. And so we have people working on each one of those areas.
Sounds great. John, do you have anything to add?
Yeah, I'll say one of the really unique things about ERDC is that we have the ability to work on both military problems and civil problems. And I think either one of those is certainly high impact, whether we're supporting troops and preparing for and avoiding conflict, or whether we're supporting, infrastructure, national assets. And it's really interesting to be able to see how sometimes the same research can support both areas. So, I mentioned some of the ways that we have of understanding ice strength for landing an airplane on ice, but we use some of those same techniques for understanding and interpreting ice layers and snow layers in the environment for one of our projects with the Corps of Engineers called Snow-Informed Reservoir Operations. So understanding how much snowfall up in the mountains over the winter can help us better understand when and how that snow is going to melt and turn into water flowing down in the rivers and streams. And that can impact things like flooding and also things like irrigation for crops and things. So that same capability can be used both for military and for civil works to improve the lives of Americans.
So in engineering a secure and resilient future is another central focus of our show this season. So what does the concept of resiliency mean in your laboratory, and how important is it to your research?
I'll go ahead and take that one. In the cold, resilience is key, and being able to have resilience, whether it's in those civil works operations or in military research, is critical, and particularly if we're talking about potential operations in the Arctic in the extreme cold. Justin mentioned how do you keep soldiers hydrated when all the water tends to freeze? There's a lot of things that we do that promote resilience. I'll tag another civil works example, just kind of pulling on the thread that Justin mentioned with ice and the impacts of ice. So we have a project with the Detroit district up in Michigan on the Sioux Locks on the St. Mary's River, and these locks are a critical component of civil infrastructure, keeping ships and barges moving goods throughout kind of the Midwest and into really the rest of the country. And when ice jams up those locks, it stops the flow of goods, and it's a huge economic cost. Every day that those locks aren't operating is an impact not only in dollars and cents, but also just in things that people can buy. And we're all aware of fuel prices, being able to move fuel and things through there is really important. So we've been working with the Detroit district to better understand and mitigate ice flows, things like cascading air screens, ice deflection, ice-phobic coatings that Justin mentioned, radiant wall heating. All these work together to really proactively address the significant challenges posed by winter navigation and ensure that the locks can remain open and ships can keep moving.
So important. Justin, do you have anything to add?
I think that our permafrost tunnel in Fox, Alaska is an amazing laboratory, and if you think about it, the U.S. military has a lot of infrastructure built on permafrost. Bases, barracks, landing strips, and the permafrost is melting, and we need to understand how quickly it's melting, how it's melting, and then how those impacts are going to reach or play out, not only from a military standpoint, but there's also a lot of homes and roads and schools built on permafrost as well. So that's another area and that we are working on, and the permafrost tunnel is a really extraordinary asset in that research.
Justin, you've been to it, haven't you?
I have multiple times, and it's a great trip. You just don't want to wear clothes that you don't mind having a kind of a smell on them, and and surprisingly, it's dusty in there as well. So you got to clean your shoes before you hop on the flight back home.
Wow, that's interesting. So when we talk about engineering a secure future, we often talk about or think of technology. How is CREL providing the nation with better intelligence on ice conditions and polar changes?
Yeah, I'll jump in on that one. There's a lot of things that we do to kind of understand situational awareness, domain awareness in the polar regions, in the Arctic, in the extreme cold. One of those has to do with our geospatial capabilities, linking back to one big ERDC. We have a geospatial research lab, but we also have a Corps of Engineers Center of Excellence for Geospatial Science here at CREL, working closely together with other folks at ERDC. One of the tools that we developed here was called the Geospatial Repository and Information Distribution, or GRID, and that provides kind of the geospatial or mapping basis on which lots and lots of different tools are then added on top of. So the first thing you need to know is where you are, and then after that you can do things, whether it's navigation or movement or largely anything that soldiers do kind of starts with a map. Mm-hmm. And one of the things that we use that for is sensing. So we have a lot of different ways of sensing. I already talked a little bit about sensing snow and ice, also sensing the permafrost that Justin just mentioned. So being able to link that exquisite sensing, whether it's from a drone or a satellite or a sensor that a soldier carries out in the field, to know exactly where that is on the map and what that means for whether it's infrastructure, whether it's movement, whether it's where we're going to put a base or where we're not going to put a base, something like that. That permafrost, it's a real good example. I'll pull that thread just a little bit more. Justin mentioned how very much of the civil infrastructure that we have up in Alaska is built on permafrost. Mm-hmm. And as permafrost, maybe I'll back up one step. Some people might not know what permafrost is. So it's soil that has remained frozen year after year, and that soil includes chunks of ice, chunks of frozen soil, and then bacteria that have been frozen in that soil for thousands, sometimes tens of thousands of years. That's where some of that smell Justin mentioned comes from. It's a really interesting material, and as permafrost melts, you can imagine if there's a bunch of water that's frozen into ice underneath, for example, the foundation of your house, that's going to cause the foundation to shift and move. And shifting foundations creates cracks and structural problems in buildings and can sometimes render them completely inoperable. And so what the permafrost tunnel does is it helps us to understand what happens as permafrost changes, right. What happens under the surface, what happens on the surface, over the surface. And so for infrastructure that we already have built on permafrost, we can better understand what's going to happen to that, which structures are going to need reinforcement, which ones could be in danger of future structural problems, and also then where we should and maybe shouldn't build future structures. And that's particularly important as we're looking at increasing our presence in the Arctic, in Alaska, working with our partners in Greenland, understanding potential threats. So understanding that permafrost is critical, and the permafrost tunnel is one of the only places in the world where you can really understand how permafrost interacts with the environment and changes.
Okay. Justin, do you have anything to add?
No, I think John answered that perfectly.
Okay, great. So we'll go into the next question. So CREL manages some world-class facilities like the permafrost tunnel and the ice extreme cold chamber. So how do these unique tools allow ERDC to engineer a safer, better world?
I think that we're very fortunate that we have the extraordinary ability to create in a controlled lab setting conditions that are very, very hard to both replicate and work in the natural environment. So, for example, in our frost effects research facility, we can freeze and thaw a section of road hundreds of times to see how the materials used to make that road react to that freezing and thawing process. If we were to try to do that in the natural world, we might be able to measure that twice a year, right? You know, once in the fall or winter when it freezes, and once in the spring and the summer when it thaws. And that's all you'd get for a year. So we're able to do that many different times, and we can also outfit that road, that sample road in the facility with a countless number of sensors to record really high fidelity data. And again, that's very difficult to do in the natural world as well, because you have all sorts of other signals and things that would make it difficult to tell to answer the questions that you're really trying to answer. So. And another example is our materials testing laboratory. You want to talk about unique facility, our materials testing laboratory. In there we have a cold box that has gone down to negative 285 degrees Fahrenheit. Now, you might ask, why would we ever need to get anything that cold? Because those are not temperatures that are seen anywhere on Earth, and that's correct because we see them in outer space. And we work with NASA, we work with other partners to test materials that will go in outer space, because there's no air, or there's no margin for error, right? Once they send something into outer space, it has to work, and you can't just send stuff into outer space to test for future missions. So it's not practical to run an experiment like that in outer space. But fortunately, we can replicate that, and we can do that right here in Hanover, New Hampshire.
Wow, John?
Yeah, I'll just kind of foot stomp on that. Having so many unique cold-specific research facilities really enables us to serve the public interest. So a couple of quick examples I'll throw out. We were just recently approached by the National Geospatial Intelligence Agency. They run these really cool gravimetric sensors where they sense very small shifts in gravity based on where you are on Earth and kind of what's under your feet. They need to go do some testing down in Antarctica, and before they get there, they want to be sure that their equipment is actually going to work in the extreme cold there. So they're talking to us about coming and testing their equipment in some of our facilities to be able to, like Justin said, cycle cold and warm, and then just turn on the cold and see how well things work. The other one that I think is really interesting, we have a facility where we can grow ice and then see what happens during an oil spill, and what the best way is to remediate that oil. As kind of resources up in the Arctic continue to expand, there's more and more opportunity for potential oil spills, and understanding how oil spills can, what happens when oil gets under the ice instead of just on a wave. What happens if you try and get rid of it by setting it on fire. A couple weeks ago, we had some tests with the EPA and others that were here monitoring everything, and we had ice sheets out with oil on the ice, and we set it on fire and measured what happened. Really interesting to watch as the fire and the ice combine in really interesting and unique ways.
Wow. So if you can believe this, we are fixing to wrap up. But before I ask this last question, I just want to thank you guys for what you do for your community, for the region, and for the nation. So it's so important with all this research, and we thank you guys for what you do. And so looking ahead, are there any key takeaways you want our listeners to understand about the importance of the work being done at CREL?
Yeah, sure. I'll take this one and wrap up. I mentioned up at the top that CREL is the only cold-specific research lab in the U.S. government, which is really important for a lot of reasons. I recently heard a stat that 80% of the Earth gets down to or below freezing at some point during the year. So cold science is impactful in a lot of different places. And certainly as temperatures change and we have more accessibility up into the Arctic for things from military operations to industry to sea shipping to tourism. There's a lot more accessibility, but that's also a lot more opportunity for conflict, for accidents, for search and rescue. We partner with folks like the U.S. Coast Guard as they're building a fleet of new icebreakers that can support research up in the Arctic to help better understand what happens in some of those unique areas. We're doing some work with them to help ensure that those icebreakers work properly. There's just really a lot of things that have happened, will happen, and are happening up in the north. And the capabilities we have, both the exquisite facilities that we talked quite a bit about, and certainly the researchers who run those facilities and understand how they impact the science and technology that we work on every day, are going to be critical to make sure that we can not just survive but thrive in those really cold conditions. Anything from civil works to military operations.
Perfect. Justin, do you have anything to add?
I think I would wrap up this whole conversation by saying that I think we have two things that come together here at CREL that form a really incredible asset for the nation. And number one is our people, of course. Number one, we have 200 plus people who are experts in their field. 56% have advanced degrees, and they are really curious and really interested in solving these problems. And that's our number one asset. And number two, then you combine that with facilities that you just can't find anywhere else, that do things that really can't be replicated almost anywhere else on Earth. And so that's a really powerful combination. And for me personally, it's an honor to be involved in that and then the work that takes place here.
Perfect. Well, Jonathon, Justin, thank you guys so much for being on the show today. It's been quite educational and learning about CREL.
Thank you, Annette. We really appreciate it.
Absolutely. And thank you for listening. And we will, if you tune in next week for another episode of Beyond the Gates.